Okay, we're going to have an example here of a parameterization of the unit circle. So since x squared plus y squared equals 1 is the equation of the unit circle, and the identity cosine squared t plus sine squared t equals 1 holds, then x equals cosine t, y equals sine t is a parameterization of the unit circle. Okay, so that's the Pythagorean trig identity, is the cosine squared plus t plus sine squared t equals 1. Another way to parameterize the unit circle is switching the two, making x sine t and y cosine t. And the difference between these will be where they are at time t equals 0, where the point is at time t equals 0, and which direction the point is moving around the circle. So the first traces a point around the circle in a counterclockwise direction, and it actually starts on the x-axis. And the second traces a point moving around the circle in the clockwise direction. And let's see, time t equals 0. Yeah, and that actually starts on the y-axis, on the positive y-axis, going in clockwise direction. So you can tell this by graphing some points, starting with t equals 0. Cosine of 0 is 1, sine of 0 is 0, so you get the point 1 comma 0, which is this point here. So at time t equals 0, I'm here. At pi over 2, cosine is 1 over square root of 2, sine is 1 over square root of 2, and so you're right around at this point here, where x and y are the same, and they're both positive, right around this point. At pi over 2, cosine of pi over 2 is 0, sine of pi over 2 is 1, so you're at the point 0, 1, which is right here. So you can see it's moving counterclockwise, right? And then if I jump ahead to pi, at pi, cosine of pi is negative 1 and sine of pi is 0. So my point is negative 1 comma 0, which is this point here. And then I did one more, t at time 3 pi over 2. Cosine of 3 pi over 2 is 0. Sine of 3 pi over 2 is negative 1. So this is the point 0, negative 1, which checks out right here. So it's going counterclockwise. And you can keep going by just increasing t. So it's just cycling around the circle as t increases. Okay, now for the other parameterization that I had, x equals sine t, y equals cosine t. At 0, when t is 0, remember you're thinking of t as an angle here. When t is 0, sine of t is 0, and cosine of t is 1. So this is 0, 1, which is the point right here. You have to be careful about these on this one, because it does not agree with the SC plane, or the CS plane, which is different, although related. At pi over 4, sine and cosine are the same. They're both 1 over square root of 2. And so that will be the same as what pi over 4 was before in the previous picture, previous graph. At t equals pi over 2, sine of pi over 2 is 1, and cosine of pi over 2 is 0. So that's 1 comma 0, which is this point right here. At time t equals pi, sine of pi is 0, cosine of pi is negative 1. So that's 0, negative 1, which is this point here, right? I'm just graphing points just to get used to it here. Okay, at t equals 3 pi over 2, sine of 3 pi over 2, 3 pi over 2. It's not 3 pi over 2. Oh, yeah. I'm sorry. T is 3 pi over 2, not the angle in the picture. That's the thing then to get confused about here. So sine of 3 pi over 2, sine of 3 pi over 2 is -1, and cosine of 3 pi over 2 is 0. So you get -1, 0, this point right there. So the weird thing here is these angles, or these values for t, are not corresponding to angles on this graph. So that's a little bit confusing. You're just plugging the number in to find the coordinates of the point. Okay, so this is in the xy plane that this is happening, not in the CS plane.